The KH-9, commonly known as Big Bird or Keyhole 9, was a series of photographic reconnaissance satellites launched between 1971 and 1986. After gathering important information about missile sites, ammunition, ships, and aircraft from Chinese, Soviet, and other foreign territories, the satellite would drop its film rolls in recoverable capsules that were then caught in midair by C-130 aircraft or retrieved manually after landing in the ocean. On its first mission, one of the film buckets containing highly confidential information sank 16,400 feet deep into the Pacific waters. Its recovery led to a secret mission that tested the Navy's deep-sea recovery abilities like never before. From 1959 to 1972, the Corona satellite program, operated by the CIA and the U.S. Air Force, oversaw almost a dozen reconnaissance missions photographing and surveilling the USSR, China, and other targeted regions with its low-resolution camera. After years of successful service, the National Reconnaissance Office began developing a replacement for the Corona satellites. The objective was to be able to search larger areas with a medium-resolution camera. The KH-9 Hexagon became the NRO's newest recon satellite. It carried two main cameras, and subsequent missions also accommodated a mapping camera. For most of its journeys, the satellite would require 4 re-entry vehicles, with a 5th added for operations that included the mapping camera. Upon flying over the desired reconnaissance area, the Kodak photographic film from the 2 cameras would be sent back to Earth in recoverable re-entry vehicles. After enduring the re-entry heat, the bucket would deploy a circular parachute and slow its descent. The capsule would then be caught mid-air by a U.S. Air Force aircraft using a claw-like device. The capsules were also designed to land in the middle of the ocean. To avoid being stolen by other nations, a salt plug in the base would dissolve within 2 days, and the film would sink. From September 1966 to July 1967, the Hexagon subsystems contractors were selected. Lockheed Missiles and Space Company was awarded the contract for the satellite basic assembly, and McDonnell was chosen to develop the re-entry vehicle. Other contractors such as Perkin-Elmer and RCA Astro Electronics divisions were selected for different subsystems. The Hexagon had a 1,350-pound film supply, the largest of any other American satellite ever created at the time of its construction, and over 1,000 people worked on its development. The Hexagon's ground testing was completed in May of 1971. The satellite was then shipped to Vandenberg Air Force Base in California aboard a massive 70-foot container. On June 15, 1971, the first Hexagon mission was launched. 5 days later, the first bucket containing over 40,000 feet of valuable film separated from the Hexagon and re-entered Earth over the Hawaiian Recovery Zone. According to several C-130 Hercules pilots responsible for conducting the film's mid-air recovery, the capsule's parachute malfunctioned, and they witnessed how it landed on the water. Luckily, a set of divers retrieved the capsule before it sank. Imagery received from this first bucket covered more than 60% of all known Soviet missile sites. A set of photographs taken as the Hexagon flew over Albania also allowed the identification of the country's entire inventory of aircraft and ships. 6 days later, on June 26th, a second bucket containing 52,000 feet worth of film footage was successfully caught by an aircraft. On July 10th, a third bucket's parachute malfunctioned, and the 1,100-pound capsule hit the ocean, sinking 16,400 feet upon impact. Accounts vary on what actually happened, and crew members waiting in ships and aircraft reported contradictory signals to each other. A helicopter crew spotted the drogue parachute with the strap hanging off, indicating that the main capsule had become detached while on re-entry. The men saw the object hit the water and then sink. When ship crews arrived at the area, they discovered discolored water from a location dye marker and bubbles without debris. Because of the parachute issues encountered on the first buckets and the third capsule's apparent loss, Hexagon operators placed 50% less film roll aboard the fourth and final bucket to reduce its weight. On July 16th, the bucket was safely recovered, reporting no issues. Even though the first KH-9 Hexagon mission was considered an astounding success, losing the third capsule was disappointing. However, a sudden possibility of recovering the device brought new hope. During one of the tests run by Eastman Kodak during the Hexagon project test trials, a 10,000-foot sample film roll was sunk into simulated Pacific seawater at deep sea-like pressure. The team found that the sample was still usable after 5 days underwater. As soon as the KH-9 Hexagon mission was over, NRO officers began pondering the idea of recovering the third bucket. The value of the recovered footage was worth the risk. An Army major working for the NRO sent a message to the Undersecretary of the Air Force and Director of the office, John L. McLucas, summarizing the importance of retrieving the bucket, no matter the cost. He stated that, quote, "The potential gains from the recovery of RV-3 would far outweigh the moderate funding required. It is appropriate that an attempt be made." In a July 27th meeting, CIA Hexagon Sensor Subsystem Program Director Donald Patterson concluded that recovering the third bucket was feasible. It was highly likely that the film would still be usable, albeit with a slight degradation. In late July, the NRO began developing a plan to retrieve the bucket with the help of the US Navy. Together, they planned a bold rescue mission that would become the deepest underwater operation of its kind ever conducted. To ensure the highly classified payload safety and keep sunlight from damaging the film, the capsule would have to be retrieved at nighttime. At 120 feet before reaching the surface, a team of divers would cover the object with dark fabric before transferring it to a ship. According to high intelligence officials, the operation was a win-win for both the Navy and the NRO. The decision to attempt the retrieval stemmed from both the film's high intelligence value and further exploring the capability of deep oceanographic recovery. To accomplish this goal, the Navy would use their state-of-the-art Trieste II deep-sea vehicle. On November 3, 1971, the Trieste II team began searching for the sunken capsule around the area where the parachute landed. Although they detected several sonar signals, they could not find the bucket and aborted the mission after 10 hours. Bad weather delayed a second search operation, but it finally happened on November 30th with additional Navy support. On the way down, the Trieste II operators encountered mechanical problems, as well as a malfunctioning Doppler sonar. Although the team was finally able to spot the sunken bucket, the technical issues rendered the submarine incapable of retrieving it. After 2 days, the mission was called off. In January of 1972, Hexagon Program Manager Colonel Frank S. Buzzard sent a message to NRO Staff Director Colonel David D. Bradburn, expressing his concerns over not performing a third attempt. Buzzard speculated that the Soviets most likely knew that the Americans were trying to retrieve the item from the bottom of the sea. If neglected, the Soviets could recover it, as they already had the capability to reach objects as deep as 33,000 feet. According to Buzzard, the Russians had, quote, the same territorial rights in the ocean as we. If we abandon the site, they can move in. We should not abandon the site until our objective is achieved. If we abandon the site without achieving the objective, we should perform all actions that make it appear as if we have retrieved. On April 25, 1972, the Trieste II recovery team attempted a third and final dive to recover the film bucket. After a 2-hour descent and a 3.5-hour search, they sighted a massive metal and wires along with 2 jagged gold foil pieces. Then, finally, the team spotted the missing capsule embedded in the sea floor. When the team recovered the item and sent it to the surface ship to be analyzed, only the bucket's upper stage remained intact. The retrieved film stack underwent extensive analysis at Eastman Kodak. It was determined that the recovery vehicle broke apart as it crashed into the water, and not due to prolonged exposure to seawater, depressurization, or the ocean floor's high pressure and low temperature. Only 25 feet of film was recovered from the bucket. Although the film roll from the third bucket was mostly lost, the recovery mission achieved another purpose. It shed light on Navy deep-sea recovery expeditions. The Hexagon's film recovery missions were among the boldest intelligence and underwater exploration operations of their time. Out of the 20 subsequent launch attempts by the National Reconnaissance Office, all but one were successful. Throughout the KH-9 Hexagon program's life, the individual satellite's durability increased steadily. The final Hexagon was launched in April of 1986 and operated for 275 days. In 2011, the KH-9 satellite program was declassified, and several documents and footage obtained from the device were revealed to the public. After receiving the footage from the first KH-9 Hexagon mission, the director of the National Photographic Interpretation Center at Kodak's Film Processing Center sent a message back to the NRO that said, quote, "My God, we never dreamed there would be this much this good." Years of spatial exploration have left the outer atmosphere cluttered with countless pieces of metal and debris, and experts estimate that this could cause a catastrophic event if it goes out of control. Scientists were then tasked with finding a quick solution to lay all the useless spacecraft carcasses instead of having them circling the Earth for eternity, and the answer was found on the planet itself. A so-called space station graveyard lies far into the southern Pacific Ocean, a unique place as desolate, remote, and mysterious as space itself, the farthest spot from any land on the planet, so isolated from the ecosystem that there's barely any life form at all. And there, thousands of meters deep into the dark ocean, lay the remains of myriads of spaceships that have served their purpose. Welcome to Point Nemo. After completing their life cycle, spacecraft become hazardous to the delicate balance of Earth's orbit. Debris left in space has increased to alarming levels, and these parts orbit the planet at speeds that often reach 17,500 kilometers per hour, potentially weaponizing even tiny specks of paint. There are innumerable bits of space junk that pose a threat to spacecraft in orbit, and NASA is significantly concerned. As the agency explained, quote, "There's so much junk that we're worried one tiny collision could trigger a big chain reaction. This possibility is called the Kessler effect. Such effect, or syndrome, refers to a potential scenario where the amount of debris in orbit reaches a critical mass, a point of no return, where one collision creates a cascading succession of crashes that create even more projectiles. After reaching that point, the orbit would be rendered unusable." NASA added that, quote, "Anyone launching something into orbit these days has to have a plan to either send it into a graveyard orbit or send it back down to burn up in Earth's atmosphere. Indeed, spaceships are not designed to survive re-entry. Satellites farther from the surface can be blasted into space and into a graveyard orbit by simply using the last bit of fuel they have, preventing any harm whatsoever. On the other hand, satellites roaming lower can be nudged out of orbit. The smaller ones are entirely burnt up upon re-entering the atmosphere and eliminated. However, those that can resist the trajectory are hard to control, sometimes landing in unexpected territories like the Skylab space station in Australia. Evidently, it's preferable to ward off debris and guide it to a touchdown point as far away from inhabited land as possible, or a splashdown location for that matter. With over 1,000 miles of deserted ocean in every direction, the pole of oceanic inaccessibility is the loneliest site on planet Earth. So much so that if someone happened to be there, they'd be closer to astronauts in the International Space Station than any other human on the globe. The closest landmasses to the location are the Pitcairn Islands, Motunui in the Easter Islands, and Mar Island in Antarctica. Hrvoje Lukatela, a Croatian-Canadian engineer, calculated the exact coordinates of the Earth's most remote location and didn't even visit the place. Using a geospatial computer program to triangulate the farthest place equidistant from 3 different coastlines, Lukatela pinpointed what was thereafter called Point Nemo. The moniker is a tribute to the famous captain of the Jules Verne novel 20,000 Leagues Under the Sea, and also a word coming from the Latin for no one. It is highly possible that no human has ever crossed this position. Furthermore, the desolate place is not only devoid of human life, but also virtually of any species. There's a massive whirlpool of currents within the South Pacific Gyre that blocks nutrient-rich waters from the area, making it impossible for most life forms to flourish, except for bacteria and an implacable type of crab. Although Point Nemo was classified as the least biologically active region amongst the world's oceans, scientists were astonished to discover a peculiar sound roaming the depths of the southern Pacific Ocean in the late 1990s. Moreover, it was one of the loudest underwater sounds ever recorded so close to the pole. The enigmatic sound was dubbed the bloop and was captured by microphones more than 3,000 miles away. The team at the National Oceanic and Atmospheric Administration could not fathom a creature large enough to produce such deep noises submerged so low under the surface. Other than the famous tentacled beast from H.P. Lovecraft's short story The Call of Cthulhu, no explanation seemed possible. That 1926 story dwelt in the lost city of Relics, which was astonishingly close to the exact coordinates of Point Nemo and the location where the sounds were recorded. The bizarre coincidence led to enormous speculation on whether mythical creatures actually existed deep into the Pacific. However, it was eventually discovered that the sounds came from colossal blocks of ice breaking off from Antarctica. Because of its remoteness from human settlements and shipping routes, it was decided that Point Nemo provided an unrivaled site for a space cemetery where obsolete satellites, rocket parts, and whole space stations are sent to rest. Countless spaceships that endured the extreme conditions of outer space and the rough descent towards Earth are now buried 4,000 meters under the sea. In 2001, the Russian space station Mir was put out of service. To bring it back to Earth, a cargo ship docked with the craft pushed it out of orbit. And even though several parts burned during the fall, about 25 tons survived and plummeted to the bottom of Point Nemo. From then on, outmoded satellites and rocket parts have joined the station. Ironically, the Jules Verne, an automated transfer vehicle that was used to deliver cargo to the International Space Station, also lays there. It is also likely that the International Space Station itself will share this destiny sooner rather than later, as the football field-sized facility has been reported to show cracks and fissures. However, it is not queued for imminent demise yet, and has been authorized to operate until 2024 at the very least. Alice Gorman, a space archaeologist from Flinders University, stated, quote, "People involved would acknowledge that at some point it will come to an end. but it has been planned for. The process of deorbiting and re-entering has been closely studied by engineers at the European Space Agency, and the data they've collected has provided a guide to ensure a controlled re-entry of the ISS when its time comes. However, as Gorman explained, the ISS comprises innumerable parts, including modules for housing the astronauts, laboratories, bathrooms, a gymnasium, and a spacious bay window. What's more, it has externally mounted solar arrays and robot arms. The expert explained that, quote, "If they do have to separate some of the modules from each other, that's likely to create some debris. As it enters the atmosphere, it will start to break up. One reason Point Nemo is a good place is that the debris footprint, from the first bit to the last bit, can be kilometers and kilometers long." But there are reasons to be cautious. Gorman added that there's a high possibility that something could go wrong, and the water could be polluted with toxic substances. Nevertheless, the space archaeologist clarified that all volatile fuels run out before impact, leaving only mostly safe materials like stainless steel, titanium alloys, and ceramic pieces. She concluded, quote, "We send it down to the bottom of the ocean, and like shipwrecks, the world over it becomes a habitat, a coral reef, a whole new life." During the Cold War, the space race prompted the US and the Soviet Union to develop an astonishing array of high-end innovations that pushed technology to boundaries that had never been seen before. Russian cosmodromes, constructed in the 1950s, showed how far the USSR's technology had evolved since World War II had ended. The Baikonur and Plesetsk cosmodromes alone have had more than 3,000 launches ever since. And on their way to orbit, Russian rockets have left more than 4,000 tons of high-tech waste scattered across miles of land where people live. The locals have grown accustomed to it. The rocket's intense red lights, the deafening roar of the launches, the small tremors, and the up to 10-meter pieces of debris that rain down upon villages and forests in the vicinity are part of their everyday life. They used to evacuate come launch time, but now some eagerly face the danger to catch riches falling from the sky. The Altai mountain region of Asia is a mostly peaceful and quiet place. Its natural formation serves as a boundary between the Kazakh steppes, the frozen forests of Siberia, and the arid plains of Mongolia. Various landscapes, animals, and peoples interact in these lands. Civilization has never had a strong presence in the region. Nature flourished with little presence of mankind. But all that changed abruptly after the end of World War II. The USSR quickly began the construction of military facilities across its borders with other countries. In the 1950s, the once calm region gave way to the most extensive and busiest spaceport the world has ever known, the Baikonur Cosmodrome. Built in southern Kazakhstan, the Baikonur Cosmodrome has been the launch site for many historic missions. It's a monument to the USSR's achievements. Sputnik 1, the first satellite to ever reach space, and Yuri Gagarin's 1961 flight were launched from this base. Almost 70 years after its first launch, the Cosmodrome is still active. Every month, commercial, scientific, and military launches occur. The Russian facility has become the primary launch site in charge of resupplying the International Space Station. However, its tremendous importance is not without its disadvantages, especially regarding the region's population, which has been forced to adapt and make a living out of the toxic waste left by the rockets. The massive traffic of rockets that launch from the facility every month generates kilometers of debris over the corridor of rocket flight paths. Modern 6-ton Russian satellites require a 4-stage Proton rocket that weighs nearly 700 tons. When the satellite launches, booster rockets peel away from the craft in 3 stages and fall back down to Earth. Those segments of debris fall violently from the sky, hitting anything under its flight path. The first stage falls within 90 kilometers of the launch pad. The second stage falls 1,000 kilometers away in the Altai region. It's been reported that some rocket parts that have rained down on villages are more than 10 meters in length. According to Russian media, the continuous flow of space debris the Cosmodrome has built up in the region since 1955 is estimated to be over 2,500 tons of waste. During the Soviet period, great efforts were made to recover the remains of the Baikonur booster rockets to preserve Soviet space program secrecy. Nowadays, the government seems not to care about them. An enormous amount of space debris has been left to rust in Kazakhstan and the Altai Mountains. Locals interviewed by foreign journalists have said that there seems to be an indirect agreement between the government and the population regarding the waste left behind. The government leaves the rubbish, and the locals get to keep the parts and scrap them for whatever use they wish to give it. Watching a satellite launch may be a one-time experience for most people, but it's a common sight for the natives of the launch area. The same can be said about getting accustomed to witnessing giant chunks of satellite wastes falling from the sky. Pieces of debris falling from the sky are often described by farmers, quote, like an angry red eye in the night, followed by a great thundering sound and a small earthquake that shakes the ground. Roscosmos, the Russian entity in charge of the launches, designates a specific strip of land across the area in which the rocket stages are supposed to occur. Paul Cooper, a journalist that visited the zone in 2018, explains that, quote, residents within this zone are given 24 hours notice of a launch to get themselves to safety, and it's only outside this zone that people can claim compensation for damages. Incidents within the zone are not uncommon. In fact, they're so frequent that the Russian Federal Space Agency has an entire area dedicated to investigating claims regarding compensations for damages caused by the launches in the Baikonur Cosmodrome. After receiving a claim, the agents investigate if it's feasible to compensate for the damage caused by falling debris. Houses, animals, and people have been hit by space debris or harmed by the toxic waste left as the years have passed. In 2008, Sergei Kazantsev, a local farmer, filed a lawsuit for the death of 4 of his horses that died of intoxication from the traces of toxic fuel scattered through a field of his. In an interview by the Moscow Times, Agent Vorobyov said that he always arrives at an inspection with an open mind. He said, quote, if people have well-founded claims and have suffered physical harm, then we will look into it. But many people try to use these incidents for material gain. However, not all damages can be repaired so easily. In 2011, a Progress 44 capsule atop a Soyuz U rocket was heading to the International Space Station when it failed within the first 5 minutes of its launch. The rocket plummeted back down to Earth with its later stages still full of fuel. The result was a vast explosion that shattered windows up to 100 kilometers away. Luckily, no villagers were harmed, but the damage in the area was tremendous, as the toxic fuel contaminated everything around the crash zone. The risk of falling rocket debris also exists in the area around the Plesetsk Cosmodrome, located in the Mizensky district in Arkhangelsk Oblast, northern Russia. Constructed in the 1950s as the world's first ICBM site, the Cosmodrome had more than 1,500 spacecraft launches between the 1960s and the early 2000s, when the launches drastically decreased. Many of the launch boosters, fuel tanks, and fuselages from rockets dropped into the virgin forests and swamps of the Mizensky district. All that space junk has been reclaimed by nature and the people that habit the lands. In 1989, a 65-foot-long Soyuz rocket booster crashed in Mirny, 200 miles south of the Plesetsk Cosmodrome. Since the fall of the Soviet Union, just like in Baikonur, locals have made a living out of the tons of debris left by the rockets. The phenomenon of scrapping, or rocket recycling, remained hidden from the world until the fall of the USSR. Almost no one outside of Russia knew about this particular phenomenon that's become part of everyday life for people living near the 2 cosmodromes. Recently, Raffaele Petralla, an Italian freelance photographer, began documenting this phenomenon in 2017. When interviewed by the New York Times about his visits, he said, quote, my curiosity was very strong. I was fascinated by these villagers. I was interested to understand why the inhabitants of the area, despite being aware of the high toxicity of these pieces of rocket, especially the propellant heptal, highly carcinogenic, go to recover them in the tundra. Many natives have seen the launches as a unique opportunity to grow rich. A whole business has developed in the region around the debris that falls from the sky. Veteran scrap dealers track down launches with binoculars. With natural accuracy, they follow debris paths and reach the crash sites either in cars or on horses. Although it is a dangerous job, as many crash zones provoke wildfires and highly toxic vapors that impregnate the zone, in the end, it pays off. With little protective gear other than masks, the scavengers use blowtorches to strip the wrecks of their light metals and other valuables. The economic reality of the region has welcomed the scrapping business. Besides farming, hunting, or fishing, there is not much else to do. Petralla says, quote, I discovered that for the people in such an extreme territory, it is a great fortune to be able to recover these objects, to build boats and sleds, above all to be able to fish in summer and hunt in winter. The durable metal that covers the outer part of the rockets is very resistant. The space junk recovered by the scrappers is used for a variety of things. Besides hunting or fishing, farmers, for example, use the metal carcasses of rockets for building roofs and stables for their livestock, including shovels and other farming essentials. Human imagination has helped the people make the best out of the situation. However, there has been a price to pay. Rocket fuel used by Russian rockets contains highly toxic components, such as heptal, which has been linked to cancers and even birth defects. A significant amount of the debris recovered contains the remains of these harmful materials. When scrappers approach the wastes carelessly, most often than not, they come in direct contact with these materials, which directly harms them. Healthcare studies conducted in the region have shown alarming results regarding health problems. In 2005, a Nature study showed children in affected areas were twice as likely to develop endocrine and blood disorders. In some locations, an elevated percentage of children are born with jaundice. Doctors explain that the spread of space junk and toxic compounds are the cause of the problem. Additionally, the waste makes its way into the food and water, damaging the entire ecosystem. Humans have found animals blinded by toxic chemicals. For a region that depends on agriculture and livestock, the effects are devastating. The Russian government has vehemently denied any link between the debris and the ongoing health problems. When asked about this, Petrala said, quote, "This is another example of how the poor always get the toxic waste, and sometimes they even profit from it, but at the expense of their air, health, and longevity."